Okay, boss. In the last class, in the demo, we have seen what is HANA and what are the different use cases for SAP HANA. When I say use cases, HANA being a database, how can it be leveraged? And once you understand the business requirements, you should be in a position to identify, okay, for this particular business process, I can leverage HANA. That's what it is. So we've been seeing about leveraging HANA as the backend database for existing SAP applications, or you can develop your own custom applications with HANA native development, or it can be used as HANA Enterprise HANA, where you can basically use it as an centralized database, have the data pumped into it, and then you build some virtualized models and then do reporting. So anyway, you can use it. That's what we've been seeing in the last class. Now, for today, our focus will be on why is it there's been a lot of buzz around this word SAP HANA and why is it so fast? In the last class, we've seen that it is an in-memory database where it is going to store and process your data in memory, right? So, so we understand that the performance of reporting on this is very fast. Why is it so fast? What is that in HANA which is making the performance of processing of data really fast? That is what our focus on this topic. Okay. Look at this. Now, if you look at this, now what makes HANA so fast? Okay. So there are a couple of reasons which are coming from the hardware development, and there are a couple of improvements which is being developed from the software perspective, which is making HANA fast. There has been certain developments from the hardware perspective, and there have been certain innovations from the software perspective together, which is basically resulting in the performance of SAP HANA. Okay, now look at this. Now, first thing when you say hardware, it's like we multi-core, massive multi-core parallel processing. We'll see what is core, and then about processing and storing your data in main memory. That is another point, which is basically from hardware perspective, it is two things. One is massive parallel processing of processors, cores, okay, multi-core processing, and then about storing data and processing data in main memory, which is actually improving the performance of processing of data from the hardware perspective. Now, if you look at from the software innovations, it's about column store and there's something called row store. In normal relational database, like Oracle or SQL Server or MS Access, whatever it is, you basically, any database ultimately stores data in form of a table in a structured format with rows and columns. But there you are basically store that in form of a row store tables. But in HANA, you have a flexibility of storing that as a row store table as well as column store tables. So we'll see what is column store table and how does it benefit us. Also, we'll see that. And so even because of column store database tables, it is improving the performance of your processing of data. Okay. And then about compression. So SAP HANA does leverage some concepts of compression. It has been understood that, say, let's say now you're storing data in Oracle. Okay. Now you take all this footprint, all this database into, let's say, HANA. At minimum, it gets compressed by 4 times. Minimum. Okay, there are cases where it gets compressed by 36 times or 15 times, but minimum it is understood it compresses by 4 times. They do leverage something called dictionary-based integer coding and positioning indexing. We'll see that, through which they're basically storing data more intelligently with less space. Because you're storing data in main memory, right? Even though it is become cheaper, but it's compared to disk, it is costly. So they just want to have some certain mechanism where they store more data with less space in a compressed format. So even that innovations is helping us to reduce the space also. Okay. And then partitioning. This is about, let's say you have multiple cores. We'll discuss on this. Let's say you got multiple cores and you split data across multiple cores, like with about partitioning. And then during runtime of the query, you basically use multiple processors and process this data parallelly and improve your query performance also. We'll see that. And then we have no more need aggregates. When you say no more you need aggregates, normally if you look at BW, you'll have info provider like Cube, which could, let's say you consider Cube to be detailed, you go about building some smaller cubes which you consider to be as what? Aggregates. Let's say cube is more detailed data, and then you build some aggregate which is more of aggregated data, and then use it for improving your query performance. Even people from BO background, what do you do? Let's say you're building universe from non-SAP source. You will have summary tables and you will have detailed tables, and use something called aggregate awareness function to dynamically decide whether it has to read data from summary tables or detailed tables, and then use it. Basically, you tend to store data in more aggregate format and detailed tables. But what SAP says, if it is HANA, you don't need to store data in a detailed format or summary. You just dump your data as you like. Because it is a column store, I don't mind whether it's denormalized or what. Just dump your data in any detailed format, and I can handle the performance. That's what. So no more summary tables or no duplicate of data. So when you're not building up aggregates which does not have summary tables, there is no duplicate of data. In other words, there is no redundancy of data here. That's again you get the benefits of this. Now let's see what is all this. Now, when you say multi-core processing, now what is this core? Now, we would have bought systems, right? We say I'm buying a system with 2 core, dual core, we say, or quad core. Yeah. So what is it like? When I say 2 core, means what? I'll have a processor with 2 cores in it. Or when I say I'm buying a system with quad core, means what? I'll have a processor with 4 cores in it. Now, what is this core? Core is actually that part of a CPU which actually processes your activity or which processes your work. So the more cores I have, and more jobs can be done at a point of time. You can understand like your work processes in SAP systems, because work process represents your RAM capabilities based on that. That's how it is. So the more the number of cores I have, the more number of jobs I can execute in parallel. That's the point. Okay. Now what they say is, now hardware has gone to the advancement where they can have a single motherboard with up to 8 CPUs in it. You'll have one motherboard with 8 processors in it. Okay. And each processor can have up to 12 cores. So with this advancement of hardware where they could go about with multiple processors in a single motherboard, and each processor having 12 cores in it. Suppose if I involve a motherboard with 8 processors in it, and each processor holding 12 cores, how many number of cores do I get in? 96. So 96 is a huge unit. Normally, if you look at systems being implemented, you implement with say 12 cores, body system. But if you imagine a system with 96 cores, and let's say if I want to go more than this, okay, what we do? Normally, when you install a server, it could be a single server or it could be multiple dialog instances. Like you'll have central instance, multiple dialog instances. Can I also combine 4 to 5 motherboards together and make it as one single server? If the sizing requirement is huge, I have single motherboard which is giving me capability of 96 cores. If I can combine 5 motherboards, then 96 into 5. That's the capability. And more the core, it's about having more cores in your server. It's about increasing the sizing of your server. Okay. And it's not about just increasing the sizing of the server. And once you have multiple cores, whenever I process data, I'm going to leverage multi-cores to access my database parallel. Massive parallel processing with multi-core. That's the point. Now look at this. You can understand this. Let's say I have a table with column A, column B, and column C. Let's say there's a table with 3 columns: column A, column B, and column C. And let's say I'm doing some reporting on top of it where I'm just trying to read 3 columns. I say select column A, column B, and column C from this table. I just run a select statement on this table to read this. Now what it does is, since there's nothing in the coding, you don't say whether it has to execute parallel processing or something. It is all intelligence of the system which does this internally. It is all internal mechanism of it. What it does is, to read data of column A, it does leverage one core. To read data of column B, it leverages another core. Okay, and let's say it sees that the cardinality of the column C is huge. It further splits the data of this column C into 2 parts. Okay, and then part 1 of C is read by core 3, and part 2 of C column C is read by another core. So 4 cores are actually reading these 3 columns and giving you the result. Obviously, when one person does this job and four people does this job, you should see a difference in the performance. That is what they mean as massive parallel processing with multi-core. Because the server has got multiple cores in it, we have the flexibility. We can leverage those multi-cores to execute in parallel. Getting this? That is what massive parallel processing with multi-cores. Because of the advancement of the hardware, we are able to have multi-cores in the server. So by using these multi-cores, we can leverage deploying parallelism while executing your queries. That's the point.
So it automatically does, or can we also?
While writing select statement, you don't specify say execute in parallel or sequentially. It is all intelligence of the system. It identifies depending on how many cores are free. It does leverage those cores to read the data. So you don't specify, okay, for column C use 2 cores, for column B use 1. No, it's all built-in programming which does that.
So it is just like our normal work process.
Not work process. For you to understand, I said it's like work process. Core is actually it's a part of hardware. When you say work process, it is a component of your SAP which represent based on the RAM capabilities. You understand this is like processor or something. Core is actually part of your processor. Actually, because all the processing is done here mainly by the processor, right? If I have processor with 8 cores, 8 jobs can be done at a time. Ante point. If I have processor with 10 cores, it means what? 10 jobs can be done at a point. It's like thread. You can understand. Like in core, will have threads. Not to get that's how you can understand. It's like component which does your work. That's it. And the more the cores I have, and more number of jobs can be executed parallelly. That's the point. And the software of HANA is designed such a way that it does leverage those massive parallel processing of your multi-cores. It's not about just having cores in the server. Your programming should leverage those multi-cores to enable parallel processing. That's the point. And HANA does that. And you don't, while writing select step, you don't never specify whether it has to execute in parallel or not. Never specify. Okay. And next point was we said it does store your data in main memory and process data in main memory. We'll discuss that in detail when you get onto the architecture. But for now, just understand every write operation into the HANA database will be to the main memory and to the disk. And every read will be from the main memory. We'll discuss in detail in that, but just for now get it like this. If, let's say you have a database, right? HANA is a database. You either write data into the database or you read data from the database. Every write you do into the database will be to the main memory and from there to the disk also. But every read, what it does, if it finds the data in main memory, it reads from main memory. If it doesn't find the data in main memory, it will read from the disk. But generally, if you have the data loaded into main memory, it reads from main memory. You'll have concepts like load and unload. When you say load, let's say I hold a table and say load into main memory, then what happens? The data of this table is loaded from disk to main memory. Then the data is available in the main memory, it is accessed by your queries. For example, let's say you have not loaded this table. So the table data is in the disk bus. Now it is not in main memory. Now when I execute a query, it does not find the data in main memory. During first fetch on the table, it does load the table into main memory, then fetches it to the query bus. If you want explicitly load, I can execute some statement say load this table in another. The content of this table will be loaded into main memory. Then when you run the query, it reads from main memory bus. But let's say you've not loaded the table into main memory, and let's say the table is still in the disk. When you execute a query, if it doesn't find the data in the main memory, it does load the table from disk. During first read on the table, it does load the table into main memory, then fetches it to the reporting or the querying results. But why is what we'll discuss. But for now, understand it does store data in main memory. But does it mean that it does store every data into main memory? No, need not. Even without storing any data in main memory, I can still have my HANA being functioning. But only if I want to improve the performance, I need to get those tables loaded into main memory. That's where you're going to have your servers with more huge RAM capabilities. That's what they do is when they're trying to do sizing of HANA server, the main calculation is about what is the RAM size they're going to need it. And based on the RAM size, 4 times of RAM would be a disk. I told you it compresses 4 times minimum. Having that logic, what they do is First, they'll calculate what is the size of the footprint. Like so when they go for sizing of the HANA database, let's say you want to install a new HANA server bus. The first thing they have to calculate is what should be my RAM size. That's the main point. So what? Let's say I have my data in an Oracle database. I would like to lift and shift this to HANA bus. So when you already have it in Oracle, do you know what is the size of the database already? Let's say you say it's 25 GB of database. Okay. Let's say 100 GB of data. Now, first thing what the train considers, I told it minimum it compresses by 4 times. Minimum, that's what they consider it. So if it is 100 GB there, okay, by the time I move it to HANA, it'll be shrink to what? 25 GB. That is what understood. So I want a RAM with capability of what? 25 GB. And then what they do is, let's say you have 25 GB of data. Then when you, let's say you're running a query where you're trying to read all 25 GB. So does it need some main memory for storing temporary results? Let's say you say take table 1, take table 2, join, then the results of this join to table 3, the results of this to join table 4. So you need some memory to store this temporary results first. So then they double this size. So if you say 25 GB and then into 2 will be what? Say 50 GB. So then RAM, I want an HANA server with of RAM sizes like 50 GB, and then they put some extra 50 GB bit and 100 GB go set this. And if they say 100 GB is my RAM size, and then 4 times of that should be my size of my disk, and storage. Getting this what? So basically, when you go about sizing your HANA, basically you specify the size of your RAM and cores, how many you want. Normally, when you go with sizing, when you specify the sizing of the HANA server, you don't specify నాకు హార్డ్ డిస్క్ ఇంత ఉండాలి అలా ఉండదు అన్నట్టు. You basically specify the RAM size and you specify your number of cores you want. So then what they do, storage under, because when you deploy this onto the data centers, like when you deploy your server onto data center, storage is not fixed. They can always jack in one extra hard disk and increase the storage bus. Disk you just specify I want a storage of 1 TB or 2 TB and all that. అది ఒక హార్డ్ డిస్క్ రెండు హార్డ్ డిస్క్లు నువ్వు ఎప్పుడు సంబంధం లేదు. మనం ఏమంటాం నాకు ఇంత ర్యామ్ కావాలి, ఇన్ని కోర్స్ ఉండాలి, నాకు ఇంత స్టోరేజ్ కావాలి, 2 TB 5 TB స్టోరేజ్ అంటే ఇట్స్ అబౌట్ దే కెన్ జాక్ ఇన్ మల్టిపుల్ డిస్క్ టు గెట్ దట్ స్టోరేజ్ అవైలబుల్. అంతే, దట్స్ ది పాయింట్. So for now, just understand it does store and process your data in main memory. So we'll discuss more on that later. Yeah. Mm-hmm. Yeah, what is it? Sir, నాకు వినపడలేదు.
Is it a non-volatile memory?
Exactly. Yeah. How does it handle that non-volatile? All this I'll discuss that in the HANA architecture. How does it handle that persistency layer? Because when you say database, it has to satisfy the property called ACID. Sort of ACID D indicates what? Durability. Means when I store some data to the database, until I delete, it has to be there for permanent. So when you say in-memory database, when you're storing data in main memory RAM, okay, which is volatile. So when I lose power, automatically the data is gone. I lose my data. But how does HANA handles that is what point. That's what we'll have to discuss as part of persistence layer. I'll discuss on the HANA architecture. But for now, it stores data in RAM in main memory and processes the data from main memory. That's what it is. But not necessarily does store every data in main memory. You can also have data in the disk. Can still HANA functions on it also. Yeah. Next, row store and column store. This is very, very important, and this is something to do with the software and which you deal with this. If you look at hardware about RAM and multi-core, you don't do anything. It's only theoretical knowledge what you get out of it. But we look at this about row store and column. This is what you basically play with in the system. So row store and column store, very, very, very important. Okay. So let's say any database you consider, okay, Oracle or SQL Server, Sybase, whatever it is, ultimately it used to use a database to store data, and in form of a table. You store data in form of a table, in more of a structured format as a table with rows and what columns. Is this a table? Yeah. Yes. Can you create table in any database? In Oracle table just so either an ultimate table and you store data in form of tables, right? But my question is, in any of those databases, when you see a table like this, do you think the table is stored in the same form in the backend in the disk? Like a matrix, does it store in the disk like that? No, you see it as a matrix like this, or a rows and column, but does it store the same way in the backend? No, boss. It does store data in some form, but when you say show me data, then it shows you with all those grids and then gives you a layout like that with rows and columns. But does it mean that it stores the same data in the same tabular format in the disk in the backend? No, right? అట్లే పెట్టుకుంటుందన్న లేదు, ఎట్ట పెట్టింటే మనం చూపమని చెప్పేసరికి అన్ని కలిపి టేబుల్ లాగా చూపిస్తుంటుంది అంతే. నువ్వు మాత్రం టేబుల్ లాగా చూస్తావు అంతే అల్టిమేట్లీ, రైట్? యా. So all the databases till now, like if you look at Oracle, Sybase, SQL Server, all this, they use roster, and Sybase IQ still supports. It was a column store in Sybase already, and that concept was got into HANA bus. Okay, except Sybase, there's no other database which actually supports columnar storage, and they had concept of columnar storage in Sybase IQ, and SAP acquired that database, and this concept was brought into HANA bus. Okay. Now let's see what is this row store and what is this column store. And in HANA, we do have row store, we do have columns, both. Only column store kaadu, rendu unnai. Most of the system tables, the standard tables or repository tables are row store, and most of the application tables are column. I will discuss why it is now. Okay. Now when you say row store, it's like this. Now let's say I've got table with 3 columns: country, product, and what? Sales. And I've got country like India, Germany, US, and chocolate, and I've got some data in it. And let's say I create this table saying create that as a row store table and anko. Then it does store data in form of like this. Yeah. If it is column store, it does store data like this. We'll discuss what is it. When I say create this table as a row store table, you understand what is row or a record in a table? This one. Complete value set of one record is one row. Yeah. So what it does, all the values of each row is stored in one continuous memory location. It takes the set of row 1, puts that into one memory location. Takes the data of row 2 and puts that into next memory location. Row 3 to next memory location. See, this is like this. So you have row 1, India, chocolate 1000, it's stored in one memory location. The next row, India, ice cream 2000 will be stored in one. I think it can continuous to be, but doesn't mean it will be in a row-wise block like that. This block could be in one memory location, say memory 1, and this block could be in memory location M20. This could be in another block M40. This could be in M60, in different places. So each row is stored in one particular memory location like that. That is row store. Okay, and if I create the same table as column store table, then what it does? All the values of one column are stored in one continuous memory location. It takes all the values of this country, say India, Germany, US, and stores in one memory M1 memory location. It takes all the values of this uh, uh, column product and stores in one memory location. Same way for what? Sales again. అంటే ఆ కాలం వాల్యూస్ అన్ని ఒక దగ్గర పెట్టుకునేది కాలం స్టోర్. రో అన్ని ఒక దగ్గర పెట్టుకునేవన్నీ దట్ ఈస్ రో స్టోర్. నేను ఇంతకు రో స్టోర్ అన్నాను, సారీ. ఒక్కొక్క కాలం వాల్యూస్ అన్ని ఒక దగ్గర పెట్టుకునేది కాలం స్టోర్ బస్. ఒక్కొక్క రో అన్ని ఒక దగ్గర పెట్టుకునేది రో స్టోర్. దట్స్. So do you understand what is row store? What is? But we'll discuss on advantages. But did you understand what is both difference? You got this? What is row store and what is column? If it is row store, each row is stored in one continuous memory locations. And if it is column store, set of the values of a particular column are stored in one memory locations like this. Okay. Now, it is all done in backend. Only thing is, while creating table, you will say create column table. You just use the keyword column. If you're creating a table with SQL, you will say normal SQL. What do you write? You say create table name, right? Here you will say create column table. Use a keyword extra as what? Column. And if you don't specify, it will be a roster. Ante. ఆ పదం తప్ప నీకు వేరే డిఫరెన్స్ ఏమి కనపడుతుంది. ఇట్స్ అబౌట్ వైల్ క్రియేటింగ్ టేబుల్ యూ డోంట్ ఫైండ్ ఎనీ డిఫరెన్స్ ఎక్సెప్ట్ దట్ ప్రాపర్టీ ఆఫ్ table type. This is all internal mechanism how it actually stores those tables we're trying to discuss. For you, while creating table, doesn't make any difference. You just use a keyword column in the SQL statement. The DDL statement of create table, you use a keyword column. but it's all internal mechanism how it handles all this. Okay. So having understood now how it stores this data, now let's say my requirement is this. Let's say first thing is I would like to understand when I'm trying to read data from this table, which table is better. I would like to analyze that. Let's say if I have a table, let's say I have a table stored in row store format. I have a table stored in a column store format, and I'm trying to read data from this table, and I would like to analyze which type of table is better for reading. That's what I want. Okay, no? So is the row store better for reading or is column store better for reading? That's what I would like to analyze. Okay, now look at this. So I say I'm trying to read. Trying to do normally when I give a universe or something on like a country, product, or sales. How does end users do reporting? Do they drag all the columns? Let's say I give them a data set with 100 columns to enable them for reporting. Do they drag all 100 columns for reporting, or they just drag the KPIs and the variables, KPI or variables, and they drag the dimensions what they want. And what they want, they will drag in those. So what I mean to say is they're not using all the columns of a table, they're just using some columns of a table. Let's say my query is like this, saying select country sales from this table. Or if it is BO, let's say you've dragged country and you've dragged sales. That is what it is. Now select Rasco, drag this to JSCO, anything. Ultimately, I'm trying to read country column and what? Sales column. Okay. Let's go through. If it is stored in row store, how does it read the data for me? What it does? It goes to the memory location of row 1. It reads what? It takes this country and then takes the sales. Okay. It goes to another, jumps to another memory location where row 2 is stored. Again, takes what? The country and sales. Again, does it jump to multiple memory locations? Let's say I've got 4 records. To how many memory locations it has to scan through? It does scan through all the 4 memory locations, but picks only the columns what it needs. At a memory location 1 కి వెళ్తుంది, దాంట్లో కంట్రీ సేల్స్ తీసుకుంటుంది. మళ్ళీ మెమరీ లొకేషన్ 2కి వెళ్తుంది, దాంట్లో కంట్రీ సేల్స్ 3, 4 అట్లా అన్ని లొకేషన్లకు వెళ్ళి కాల్స్ తెచ్చుకోవాలి. రైట్. Imagine column store, same thing. Let's say if I have my query fired out on column store table, what? Country sales. It jumps to a memory location where my countries are stored. It reads countries. It goes to the memory location where my sales are stored. It reads sales. Any memory location jump in it to 2. Is fast about column store. You getting this? So my querying was about choosing country and sales. Can I say this reporting is more like analytical reporting? When I use the reports more for analysis, I don't try to read all the columns of a table. I try to read certain column, only certain columns of a table. In that case, column store is more suitable. Can I say? Now let's say my reporting record is like this. I'm saying read all columns where country is equal to US. That is my query. My user is trying to run a report saying read all the columns, says select country, product, sales, where my country is equal to US. I'm trying to read all, like select star. I'm trying to read all the columns of a table, but for one particular row. Okay. Suppose if it is column store, then what I should do? I'll go to memory location where the country columns are stored. Pick US from here. Then go to the memory location of product. Pick what? Noodles from here. Go to memory location where sales is stored. Pick what? 500, and then show your record. Okay. Suppose if the table is stored in row store, I'll straight away jump to memory location where the detail of country US is stored. So I go to memory location 4, read this record and give you, which is faster. Row is fast in this case. Generally, when you say select star from a table, it is more like operational reporting. Normally, when they do use reports for analysis, they don't try to read all the table. They try to read only certain columns of a table. Then column store is better. But if I'm trying to do an operational kind of reporting where I'm trying to read all the columns of a table of particular rows, then row store would be faster. Getting this? So while now you understood about reading, if I need to read data from some table, now which is better? Column store or row store? Depending on my requirement. If I'm using this table more for analytical purposes, for analysis, where I try to read certain columns of the table, I would prefer going with what? Column store. if I'm trying to do more like an operational reporting where I always try to read all the columns of a table, which is never a case. Generally, atlantic case takku untundi anta. Table unna anni columns read cheyadam చాలా rare. In that case, I would prefer what? Roster. So you understood about the concept of while reading this. Now, with this, okay, I'll discuss. Okay. Next point is about inserting. Next is what? For a table, do you try to insert new data? We've discussed on how does it, what is the difference in the performance while reading. Now we'll have to understand about while inserting this. Table in the table ku kotta record పెడుతున్నా. Okay, so if I'm trying to insert a new row or new record, every time you always insert, do you insert columns or do you insert row? You always insert row by row in a table. So when I'm inserting row by row in a table, which type of table is better, row store or column store? Suppose if I'm trying to insert new record into the table, if let's say I'm trying to insert a new record saying Nepal chocolates and say 5,000 something. If it is row store, what it just has to find a memory location which is free, take the entire record and put that in that. That is in case of row store. If it is column store, what? It has to find the memory location where it is storing all the countries, go there, insert what? Nepal. Go to the memory location where the product is stored, go there, insert chocolates, and go to the memory location where the sales are stored, insert 5,000. Which is faster? Row is faster. Now, can I say while inserting, when I'm leveraging this table for inserting data into the table, my row store would be faster. ఎక్కువ చూస్తుంటే అడ్వర్టైజ్ అన్ని ఆడిపోతున్నాయి రోకే పోతుంది మరి ఇంకా సేపు కూడా కాలం పెట్టి తెచ్చినాడు అనేది కాన్సెప్ట్. Got this point? So while reading, if you're reading certain columns, column store is faster. And if you're reading all the columns, row store is faster. For inserting, row store is faster when compared to column. Does it make logical reasoning why? Yes? Yeah? Good. I know now most of you have doubt like this saying, okay, when I store with column store, I have something like country here. Let's say I've got India. And then what is the corresponding product of it? How do I know that? How does doubt in the mind? Yeah. So when I go with column store, what happens? All the values of one column, like say country, are stored in one memory location. All the values of product are stored in one memory location. But how does it know? For the column value of country India is supposed to be matching with the product what? What is the product here? Chocolate. How do I know? As long as if I don't store it this way, I don't know the relationship with those columns. Country India country ki, sorry, for country US ki product ఏంది బస్ ఇది ఇట్లుంది కూడా నీకు తెలుస్తుంది ఇట్లా పెట్టి నీకెట్ తెలుసా since I have the data represented in form of row and columns you know that for US it is noodles. But if I just give you two sets saying a country list and say a product list, how do you know for which country which product was? Kada. So do we need to have some connections, right? So it does maintain something called positioning indexing. I will discuss next slides. I'll show you, but it does use something called positioning indexing. Ante, say for country column, let's say I have India. Let's say that is first column, first value. Product లో ఫస్ట్ వాల్యూకి మ్యాచ్ అయితే ఆ నంబరింగ్ పెట్టుకుంటుంది అంటే కాలం లిస్ట్ లో ఉన్న ఫస్ట్ రోకి ప్రోడక్ట్ లిస్ట్ లో ఉన్న ఎన్నో రో మ్యాచ్ అవుతుందని ఒక లింక్ పెట్టుకుంటుంది విచ్ ఇస్ వాట్ వి కాల్ ఇట్ as పొజిషనింగ్ ఇండెక్సింగ్ పొజిషన్ వైజ్ దీంట్లో ఉన్న ఫస్ట్ కాలం వాల్యూ దాంట్లో ఎన్నో కాలం వాల్యూకి మ్యాచ్ అనమాట which we refer it as positioning indexing. We'll discuss more on how does it maintain those integers and positioning indexing. We'll see that, but for now understand that it does leverage a concept called positioning indexing. Okay, boss? Now the question is, okay, now understood, but most of the advantages are towards what? Row store. But SAP is suggesting to use column store for improving the we are saying by using column store, my performance of reading certain columns is more faster. So now what SAP want is they want to design a column store in such a way that it handles the write performance as well as reading performance. Anyhow, it is handling the read performance when you read certain columns. But they want to come out with certain mechanism where it can also handle write operation also on it. As it is based on the behavior of my column store, we are able to read certain, if you're reading certain columns of table, it is faster because each column sets are stored at continuous memory locations. అదొక పాయింట్. ఇంకో పాయింట్ కూడా ఏంటంటే, see for example, I have these values, right? India, Germany, US, right? Okay. It does actually store like this. Let's say you understand this like memory like country. India, Nepal, US, US, Nepal. Assume that is a memory location for country, and let's say you have something like what products, P1, P2, P1, P2, P1, 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 sales, 12, 14, something 15, 12, 13, 12. You have like this, okay? So this is one column in one memory location. This is another column in another memory location, and this is another column in another memory location. Okay. Then, as I told you, it will have something called positioning index, which tells me the value 1 here is matches to value 1 here or value 2 here or whatever it is. Okay. When I have this positioning indexing, which basically links up my values of a column, can I do like this? I will just say like this. Can I do this way? Then it says India matches to P1 and P2, whatever it is, it maintains a link. Now, can I reduce the size required to store this table also, if this column store? When each column is stored separately like this, I remove all the duplicates and store only the distinct values. So when I use column store, will it again reduce the size required to store the table? But you can ask me, how do I know this India matches to P1 and P2 also? With what? Positioning index. So I don't have to store distinct values. You should understand it like this. Imagine there is a table with, let's say, 100 million records in it, and I have a column called region. 100 million records, and I have a column called region. Let's say maximum I have got 4 distinct values like south, north, east, and west. I've got 100 million records. Now, normally, what do we assume? Like for region column, again, it stores what? 100 million. But when it removes duplicates, what will happen? 100 million values nunchi 4 values తెస్తే ఎంత space నీకు సేవ్ అవ్వాలి. So when I'm using column store, I'm reducing the size required to store this database. And I have this advantage also with column store. So this, you can understand this is one of the compression technique through which they are also reducing the size to store the data in the HANA database also. So can I make it a point clear? When I use column store table, I am reducing lot of space because of this mechanism. I store only the distinct values of that column, not all the values. The region ki 100 value, I've got 100 million records. Kan mottham region column chusukunte I've got only 4 distinct, south gani, north gani, east gani, west undi. When I remove all duplicates, I'll get only 4 values. Aa column ki 100 million store cheyakunte only 4 values pettukuntanu. So will it reduce the size of the database which is used to store this table? That is one advantage, right? Another advantage, do you know what is primary key? Do you understand the saying, normal ga, when you have some table, and let's say when you're trying to read from a table like this, let's say I have a table where my primary key is customer number, okay? And I'm trying to do like this, select so-and-so, so-and-so, so-and-so from this table where my customer number is equal to C1. That is one kind of query I write, okay? So I've got a where clause on a column which is a primary key of my table. Okay. Next, let's say apart from customer number, I have another column, let's say customer region, which is not a primary key. I say select star from so-and-so, so-and-so, so-and-so from this table where my region is equal to so-and-so. So there's one first query was what? We had a where clause on the primary key column of the table. The next is I've got a where clause on non-primary key column of a table. Normally for a primary key, will it have index, primary index? Yes. So do you see any difference in the performance of these two queries? Yes. When you have a query running on with the where clause in the primary key column of a table, it is faster. And when you have a when you have select running on where clause of non-primary key, it is slower because it does not have any index on it. normally when you do querying on BSEG or your CE1 tables with open SQL statements, the query performance are really bad. Then what you go about building some in S11, you build some secondary indexes on the table on those columns, then handle it, right? Yes, sir. We don't need all those when it is column store. Why? Because each column itself will act as an index for us. ఇట్లా డూప్లికేట్స్ లేకుండా పెట్టుకున్నాడు ఏందన్నా చెప్పు. Each column of a table itself will act as an index for you. In a normal table, you go end up creating secondary indexes to improve the because only primary key will have the unique index. Other columns will not have the unique index, so the performance of the queries are bad. But if you look at column store, each column just storing distinct values. Is it acting like an index? So when you place where clause either on a primary key column or non-key column, you still have a good performance in case of what? Column store table. Because each column itself can exact index gadu, it acts like index. But still there will be certain requirement where you still go building second index on column store also. Even on column store table, you will still build second indexes also if the performance is really bad. But what I'm saying, to certain extent, each column also will act as an index for me to improve the performance of the reporting. That is another advantage I have with what column store. So I considered four things. One is size, reducing the size, reducing like treating that as an index, read operation, write operation. Read was also fine till certain because when I'm reading certain columns, it is always faster. And reducing size, I was good, and then even acting as an index, I was good. But my major problem was only about what write. So SAP wanted to come out with certain mechanism in the backend for a column store table, which can handle both read and write also. Getting this? So now when you consider all these four aspects, only while writing, the performance of column store is bad. So they wanted to bring out certain mechanism in the backend, which can handle even write operations also. Because I can't do it this way. Say I create column store table for reporting, but when I'm writing, I can't convert this to row store, do load, then I can convert to column store. I can't handle it like this. Once I create my application table as column store, it will be column store. Then I do, we can convert this. I can write an alter statement, convert row store to column. I can do, but you can't do every time in the runtime like that, right? So what the point is, I will have column store to improve my reporting performance. But at the same time, SAP wanted to bring certain internal mechanism through which they can improve the performance of write operation onto the table also. Okay. See, let's see what is internal mechanism, how it handles the write operations. Look at this first. First, I'll give you very basic, then I'll change the vocabulary. So what happens is, when you create a column store table, internally it actually creates two tables. When I say create a column store table, it actually creates two parts of the table. One is part one is part two. Both are like tables. When I create a column store table, it actually creates two tables internal. One is called as part one table, part two tables. Part one, which they consider as main table, delta table. So when I go to creating a column store table, internally it creates two tables. One is considered to be the main table and one is considered to be the delta table. Okay. Main table is more like a column store table optimized for reading. Delta table is more like a row store mechanism optimized for writing. When I say column store table will represent two blocks. One is main table, delta table. Column store table. Every time I create a column store table, it will have one main storage table and one is delta storage table. Okay, numbers. Together will constitute a single table called what? Column store table. That's the concept. Okay. So one is considered to be main table and other table is considered to be what? Delta table. And the main table is more like a it's a column store table mechanism. It's more optimized for reading. And delta table is more like a row store mechanism with optimized for writing. Okay, numbers. So having two storages like this, Every time I write data into it, it is going to write into what? Delta table. Delta table is more row store optimized. It's like more of row store mechanism, right? So can I insert the record faster, right? So let's say as an user, I've inserted one record. As soon as I insert data into this table, it inserts into what? Delta store, and it gives me a message saying record has been saved. As a user, I'm not worried whether it is getting into Delta or main. I'm only worried whether is it inserting faster. It is inserted both. Asynchronously, like say after 1 day or depending on, we'll discuss that later. I'll run some process called delta merge process. We'll run some process called delta merge. Asynchronously అంటే record insert చేసి ఉండదు. Record 9 o'clock insert చేసి ఉంటాడు. 11 o'clock కొడతాం merge. It's possible. Okay. When I do a delta merge, what happens? It takes data from delta table and writes it to main table. యూజర్స్ లేనప్పుడు ఎప్పుడైతే సర్వర్ బిజీగా లేదో అప్పుడు నేను కొడతాను మర్జ్. కొడితే ఏమవుతుంది? ఇట్ టేక్స్ డేటా ఫ్రమ్ డెల్టా స్టోర్ అండ్ పుట్స్ ఇట్ వాట్? మెయిన్ స్టోర్ టేబుల్. And when you that is about writing. And when you're reading, does it read from main or delta or both? No, both. Because even before doing merging, the data is still available for reporting. Let's say I insert a new record. I have not done merging. It is still available for reporting. Yes. Why? Because when I'm reading data from column store table, it does read from main and delta. Union of both. It takes data from main, it takes data from delta, then combines both and gets to me for reporting. He is having the delta table, delta merge concept for what? To enable write operations. So whenever I go about creating a column store table, it would have main store and a delta store. Main store is more of a column store mechanism with more optimized for reading. A delta table is more optimized for writing. It's more of row store optimized for what? Writing. So every write operation will get into what? Delta. And when you perform a delta, and every read operation will be from both on main and what? Delta. And how do you move data from delta table to main table? By performing a process called delta merge. By performing a process called delta merge. ఇంకా చాలా డెప్త్ ఉంటుంది. అంటే there are different types of merge. There's something like auto. ఇప్పుడు నీ క్వశ్చన్ నెక్స్ట్ నీ మైండ్ లో డౌట్ అంటే మర్జ్ ఎప్పుడు రన్ చేయాలా, ఎట్లా రన్ చేయాలా, ఎవడు రన్ చేస్తాడు అది ఈ క్వశ్చన్ మైండ్ లో, రైట్? there are different types of merge actually. ఊరే రఫ్ గా చెప్తాను. there's something like auto merge అని ఉంటుంది. there is something called auto merge ఉంటుంది. అంటే let's say you created a column store table, and for this table you can switch on a property called auto merge అని పెట్టొచ్చు. Okay, so when auto merge is enabled for this table, what happens? Within HANA server, you'll have a component called merge dog and a component ఉంటుంది. Within the HANA server, there will be some program or there will be some component called merge dog, which is basically responsible for performing merging. Okay, so for merge dog ఏం చేస్తుంటుందంటే, when you switched on auto merge on a table, and in the server configuration, you would have maintained something called auto merge decision function between, and you would have specified some formula. And if delta store size becomes like this, that is my condition, which I put for what? Auto merge decision function. What does merge dog does is it keeps scanning through all the tables. Any table which satisfies this auto merge decision function, it triggers merge on the table. మన చేసేది ఏముంది? You have enabled auto merge on this table. Okay, you switched on the property called auto merge on. Then what happens? There will be auto merge decision function. There's a property in the server configuration saying during this condition, when this condition is satisfied, trigger auto merge function formula saying when delta store size is so and so, when the main store is so and so, and condition రాసుకోవచ్చు. You can write your own condition. Yeah? Then what happens? Your merge dog will be scanning through all the tables. Any column store table which satisfies this decision function called what? Auto merge decision function. Your system merge dog will trigger merging on the table. That is called auto merge. Automatic గా సిస్టమే మర్జింగ్ చేసేదాన్ని ఆటో మర్జ్ అంటాం బస్ అంతే. కానీ ఈ టేబుల్ మీద మర్జింగ్ చేయాలా వద్దని చెప్పేది ఒక ఫంక్షన్ పెట్టింటాం, ఒక లాజిక్ పెట్టింటాం. ఆ ఫార్ములా సాటిస్ఫై అయినప్పుడే ఆ మర్జింగ్ ట్రిగ్గర్ అవుతుంది. అది చూసుకుంటా ఉంటుంది. ఎనీ టేబుల్ విచ్ సాటిస్ఫై ద డెసిషన్ ఫంక్షన్ ఇట్ ట్రిగర్స్ మర్జింగ్ ఆన్ ద టేబుల్. అది కాన్సెప్ట్. దట్ ఈస్ ఆటోమర్జ్. ఓకే బస్. నాకు అట్లొద్దు. If delta data is huge, then delta merge is taking huge memory, where it is reading entire data from main. Yeah, if you're really worried about have delta being used, you run merging, right? You said, as first our topic question. I'll come to the discussion. Now, question is, let's say, I don't want to do merging automatically with the system. I would like to do. Ante, I would initiate whether the merging should be done now or not. I will initiate the merging, but whether merging should be performed or not, I should have some function, some decision function. That I'll call a smart merge. So again, like auto merge decision function, even for smart merge, I'll give certain criteria. When this criteria is satisfied, it has to do the merging. I'll specify some criteria for smart merge, and then I will initiate the merging, saying perform merge on this table, saying smart merge on. Then what happens? I am explicitly triggered. So system will never trigger merging because auto merge is switched off. You have switched off the auto merge property. System will never trigger merging. I will manually be triggering the merging. I will be initiating the tokenizing the merging bus. But whether merging should be done or not is decided by smart merge decision function. Every time I initiate merging, it will not do. It will do only when the smart merge decision function is satisfied, when the criteria is satisfied. Even though I initiate my merging manually, it is performed only when smart merge decision function criteria is satisfied. That is called smart merge. అట్లా డిఫరెంట్ క్రైటర్ గిట్ట చెక్ చేస్తూ కొట్టాల్సిందే అంటే హార్డ్ మర్జ్ అంటే సర్వర్ బిజీగా నా పని చేయాలంటే క్రిటికల్ మర్జ్ అట్లా ఫోర్స్డ్ మర్జ్ హార్డ్ మర్జ్ ద సమ్ క్రిటికల్ మర్జ్ అంటే ఈవెన్ దో యూ స్విచ్డ్ ఆఫ్ ఆటో మర్జ్ డెల్టా టేబుల్ size becomes to the extreme case, then system will trigger merging automatically. Even though you switched off auto merge and you forgot doing scheduling merging on this table and the delta table becomes huge level which you can't control, system will, in that cases, it does do something called critical merge, which has to be done. Atla forced merge, critical merge, smart merge, auto merge, and we'll have different types of merge. We'll see that. Don't have to. And actually, so the point now is, why should I worry about so many types of merging? Because if I enable auto merge, system will take care of doing it, right? అంతే కదండి. ఇట్లా అన్నీ చెప్పినా అనుకున్నా ఎవరికన్నా ఆటో మర్జ్ ఉంది మనం చేయొచ్చు అన్నాను. అప్పుడు ఏం చెప్తాం? ఆటో పెట్టావా వాడే చూసుకుంటాడు అంటాం కదా. Generally, when I have two options, when system is able to take care of merging automatically and when I can trigger merging, which one would I prefer? Auto merge. How does auto merge function? You'll have merge dog which will be scanning through the table. Whenever any table which satisfies the criteria of what? Auto merge decision function, it triggers that merging. Kada. Now, na problem with that is what is the problem if I go with auto merge? Let's say I have a queue or I'll have some table. Okay, I'm loading data into the table. Okay, while inserting data into the table, if you trigger merging, it will affect that loading performance. Let's say I have a table. I am inserting data into this table. During the time of inserting data, if the merging gets triggered, the performance of inserting will be slowed down. Nothing but let's say I'm loading data into the queue. While loading, if the merging is triggered, then the performance of loading will be degraded. Okay. Now let's say I have a table of a cube or table of a DSO or normal table where auto merge is enabled. And you're trying to insert millions through BODS or something, you're loading millions of data to the table. After, let's say you're loading 10 million, after loading 1 million, you find that it is satisfying the criteria for what? Auto merge. Then suddenly your merge dog finds that this is satisfying my condition, it starts triggering what? It starts issuing the tokenizing for merging. And when the merging process is going on, the process of inserting or loading is kept on hold. So will it slow down? That's a point. There are some timing where there is like block on the table. So during that time, inserts can't go doing merging. So in order to handle this loading performance, what I'll do, I'll switch. So I'll not go with auto merge. I'll switch off the auto merge completely. Let me load millions of data. Let me finish my loading completely. Then I would like to initiate the merging process. So did you understand why I should trigger manually first? Why I will not depend on auto merge?
After loading, you can trigger the auto merge.
Auto merge is not triggered by me.
Like,
Auto merge is triggered by merge doc. But once it is triggered, whether it runs or not depends on the auto merge decision function criteria.
But the condition will be specified
by we can specify the criteria for auto merge.
Is it only on
ఏం పెడతావు కండిషన్ 10 లక్షలు పెడతావు 1 million పెడతావు.
Is it only on the memory or we can mention any other criteria?
Basically, in the server maintenance, I'll specify some parameter saying auto merge decision function అని ఉంటుంది. అక్కడ వాల్యూ పెడతాను. Saying this is my criteria. You can say when delta storage contains 1 lakh records, 10 lakh records, or 10 lakh cells and పెట్టొచ్చు. But what is the size you will go? 1 lakh పెడితే రేపు పొద్దున 2 lakhs వచ్చింది అనుకున్నా ఏం చేస్తాం? You cannot always control the decision because there could be any certain criteria which doesn't satisfy then what you will do. That's the problem. So we will switch off auto merge and then we try to depends on if it is BW on HANA, we would switch off the auto merge on the tables and trigger merging through process change. After running DTP, I'll have a process which will trigger what? Delta merge and auto process. That's the concept. We'll discuss more on this part of merging later when I physically go to creating a table. We'll see data getting into row delta. I can't actually get the two tables. Internally, there are two storages. Actually, memory two storages, main storage, delta storage. But for you to understand clearly, I was referring it as two tables, but there are two tables. There are two storages, two memory locations. Memory location 1, memory location 2, which one is main and one is called delta. So do you understand what is column store and delta merge? Then depth theoretically, you know there is a concept called main and delta for a column store, and there is something called delta merging which takes data from delta to main. And every read operation is from main and delta, but every write is to delta. And how do you take data from delta to main? When you do delta merging. So do you need to trigger delta merging at the time of inserting, or it can do asynchronously? Synchronous గా అవసరం అసింక్రనస్ అంటే పొద్దున్న డేటా పెట్టి కూర్చొని రాత్రిపూట డేటా మర్చి కొట్టుకోవచ్చు కదా.
If the table size has exceeded and once it is triggered automatically, will there be any data loss?
No, there will be no loss in the data. Only problem is the table will be logged during that time. There's some timing where actually ఇంకా డెప్త్ ఉందన్నట్టు. Actually, if you get in depth, you have main and delta. Actually, it keeps changing. You'll have main 1, delta 1. Okay, when you do merging, it takes two more storages, main 2, delta 2. When there is a shift of storages like this, there's for small time the locking is done on the table. Otherwise, it's all fine. You can still read while doing, but for inserting, you'll have a lock.
Even writing data to delta merge, is there any specific limit or it can handle how many? Suppose if I have
good. See, immediately is asking me, is raising me a question on performance of delta merging. Okay, that's what I'll do to improve the performance of delta merging. I will do partitioning of table. Next level is let's say I have a column store table. I create 4 partitions on the table. Partitioning. Okay, each partition will have main table, delta table, main table, delta table. It treats each partition as a separate table. And each partition will have main table, delta table, main table, delta table. Now, when you do merging, when you say merge this table, it does perform the delta merging only on the partition where there's new data come in. For example, na cube undanda. You understand? There's a cube. For this cube, let's say I create 4 partitions. Partition 1, 2, 3, 4 and berthan, for example. Now let's say I load some data and the data comes into partition number 1. Okay. And then I do, let's say I load 1 lakh records and I do merging. And then after merging, I take this data from partition 1, from partition 4 to partition number 1 and better. Now partition 1 is blank. Now again, I load some new set of records. And let's say I load only 5 records. Let's say the 5 records are coming into partition number 4. Now I said perform delta merge. Now, do we have some new set of records in partition number 1? No. We only have new set of records in partition number 4. So where it's only 5 records. So merging is done on only those partition 4 alone. ఏ పార్టీషన్ అయితే కొత్త రికార్డ్స్ ఉన్నాయో దానికే మర్జింగ్ చేస్తున్నారు. సో by partitioning the table, I can also improve the performance of delta merging. మన క్యూబ్ లో కంప్రెషన్ ఉందా? Concept of compression. We also leverage the concept of partitioning and compression not for improving query performance now. We still use the concept of compression and partitioning to improve performance of delta merge. Even in case of BW on HANA, when I say even though you have table in detail, you can still handle query performance. Then why should I do compression? Why should I do partitioning? We are doing it for handling delta merge performance. Now we are not doing compression to improve query performance. We are doing compression or we are doing partitioning of table to handle delta merge performance. That's the main focus. So partitioning చేసి we try to improve the performance of merging. Generally, actually, there is a limitation that each one table can go up to max 2 TB max. In one table, you can store the data of size max 2 TB. And now question is, if I have requirement to store more than that, what will I do? I'll create partitions. Then each partition will have the capability of storing 2 TB. నేను ఒక 8 పార్టీషన్లు చేసాను అనుకున్నాను, అప్పుడు 16 TB పెట్టచ్చు ఒకే టేబుల్ అట్లా. When I say each table limitation is for each partition itself is treated as one table altogether. So each partition will have main storage, delta storage. If I have 4 partitions, I'll have 4 main, 4 delta. The internal concept. Actually, నువ్వేం చేయవున్నా ఓన్లీ SAP వాడు కాలమ్ స్టోర్ ఎలా హ్యాండిల్ చేస్తున్నాడు లోపల అంతవరకే. నువ్వు రైట్ క్లిక్ కూడా కొడతా అంటావు అంతే. You will just initiate a command, perform delta merge. నీకు స్మార్ట్ మర్జ్ కావాలన్నా స్మార్ట్ మర్జ్ అని అంటావు అంతే. ఇది అంత లోపల వాడు చేసేది, నువ్వు పెద్ద అంత డిస్కషన్ పెట్టుకుని వాడంతా కరెక్ట్ చేసి టెస్టింగ్ అంతా అయిపోయినాయి. మనకు వీ కాంట్ రివైజ్ ద ప్రోడక్ట్ వర్షన్, వాళ్ళంతా టెస్టింగ్ చేసి ఇచ్చేసారు ఆల్రెడీ. ఎలా చేస్తున్నాడు అంతవరకే దిస్ కాన్సెప్ట్. అదే అన్న, యూ డోంట్ వరీ వెదర్ మై డేటా ఇస్ డిస్టర్బ్డ్ ఆర్ డేటా ఇస్ డిలీటెడ్ వెన్ ఐ డూ మర్జింగ్. నథింగ్ ఇస్ హ్యాపెనింగ్.
Not about while the data is getting bigger. Suppose the delta merge will be having some space, right? Suppose if I am getting that data which is having more than the space of the delta merge.
Then that's what I'm saying. You go with a smart merge. Then what is it? And then if you exceeding, so let's say there is a table, you have switched off auto merge and you're not triggering merging at all. Let's say no one really cared about the table. Then what did I say? I said there's something called critical merge, which system will execute on it on the table. Auto merge was disabled, and you have never bothered about triggering merging. Is saying I reached to a situation where delta store becomes huge, and who is taking care of it? Kada. Actually, తెలిసిపోతాంటుంది ఏ టేబుల్. Actually, when I see the properties of a table, it clearly tells me memory size for main, memory size for delta అని చూపిస్తుంది క్లియర్గా. With that, I can know that there is this table. Okay, నేను పట్టించుకోలేదు అనుకో, అది నీ క్వశ్చన్. సిస్టమ్ పట్టించుకుంటుంది. That is called critical merge. If there is a situation where it goes beyond a certain situation, system will trigger that merging automatically. That is called as critical merge. Other any question? Okay. So we'll stop it here and we'll continue. Then still other points which is basically improving the performance of HANA. We'll see the next points tomorrow. Okay, fine.
Here I have a question in this.
ఈ స్లైడ్ ముందు స్లైడ్ ఈ స్లైడ్ చెప్పు.
యాక్చువల్లీ HANA డేటాబేస్ లోనే మనకు యాక్సెస్ సర్వర్ అప్లికేషన్ సర్వర్ ఉంటుంది.
ఓకే.
HANA డేటాబేస్ లోనే సర్వర్. బట్ ఇఫ్ వి టేక్ అవర్ నార్మల్ సినారియో, వి హావ్ డేటాబేస్ యాప్ సర్వర్ అండ్ GUI. మూడు లేయర్స్.
SAP అంట.
నార్మల్ SAP. బట్ ఇప్పుడు HANAలో వి ఆర్ సేయింగ్ దట్ డేటాబేస్ లోనే మనకు
లాజిక్ పెడతా ఉంటాం.
బట్ ఇక్కడ మాక్సిమం మనం ఏం చేస్తున్నామంటే వి ఆర్ స్టిల్ పుషింగ్ ద కోడ్ డౌన్ టు డేటాబేస్ లెవెల్. మనకి ఇప్పుడు సర్వరే డేటాబేస్ లో ఉంది ఇన్ మెమరీలో, బట్ ఆ టెర్మినాలజీ నాకు అర్థం కాలేదు. అంటే స్టిల్ సేయింగ్ దట్ పుషింగ్ ద కోడ్ టు ద డేటాబేస్.
గుడ్. ఇప్పుడు నీకు అర్థం కాలేదు ఎట్లా అంటే, నువ్వు బిడబ్లు అంటే నీకు అర్థం కావడానికి చెప్తాను. లెట్స్ సే ఐ హావ్ బ్యాక్ అండ్ HANA database. On top of it, I've got BW server, and then I've got some BEX reporting done. A front end browser lo report run chestunnam anukondi. Let's say you're running some reports. then what it does, when you run a report, it actually triggers some ABAP program in the BW server, and BW server will read the corresponding data from what? From the corresponding tables from what? Database server, and brings the data from database server to what? Application server into some internal tables. You will process it, and you might reflect the changes back to the database, or you might send it to the front end. This is the general principle of your application working in. So there is an application server. So all your logic is executed in what? Application server with ABAP layer, which is actually reading data from database, taking data into the application server, processing it, and sending it back to the front end or back to the database. So there is a movement of data from database layer to application layer and application layer to database. This is the point. This is same other than what is happening, the time taken by my program, 60% of my program is spent in reading data in and out. So I'll write an ABAP program which will basically have all my logic with scripting. And ABAP, it will be like an outer layer is wrapper is ABAP, but inside the actual logic I'll write as a stored procedure in HANA. So let's say you run a report, it triggers my ABAP program. ABAP program will actually execute what? Scripting. And script is executed what? Where? In the database. And in the database, the script runs on those tables and gives you results. ఇప్పుడు ఏం చేసినట్టు నేను ఇప్పుడు ప్రెషర్ డేటాబేస్ లో ఉందా అబాప్ సర్వర్ మీద ఉందా అంతే అది పుష్ డౌన్ అంటే కోడ్ దొబ్బ ఇది అర్థం ఈ పాయింట్ అర్థమైందన్న when I write script, I implement all my business logic with scripting in database. My ABAP program will call that script. That's it. So ABAP now in this case ABAP server is just used as a middleware layer to read the command from the front end and redirect what logic it has to execute in the backend database. That's the concept. So I refresh some report. It triggers my ABAP program. ABAP program will call certain scripting, and the scripting is getting executed where in the database layer, and the scripting is accessing data which is in what? Database layer. Now code logic database layer lo undi, na data database layer, there's no movement of data. It is straight away consuming the data which is there in the database layer, processing it and giving it to you. ఇప్పుడు నేనేమంటానంటే I have eliminated the process of moving data from database layer to application layer back to database. ఆ డేటా మూవ్మెంట్ నేను కాన్సెప్ట్ ఎత్తేసినాను, దానివల్ల నా అప్లికేషన్ పర్ఫార్మెన్స్ బెటర్ గా ఉంది అని చెప్తాను. ముందు సినారియోలో డేటా మూవ్మెంట్ ఉంది, ఈ సినారియోలో డేటా మూవ్మెంట్ లేదు. ఆ డేటా మూవ్మెంట్ ఎత్తేసేసరికి నాకు అప్లికేషన్ రన్ టైం తగ్గుతుంది, ఇంప్రూవ్ అవుతుందని నా పాయింట్. ఇప్పుడు చెప్పింది ఇప్పుడు అర్థమైందా కదా? ఎక్సెస్ ఇంజిన్ ఎందుకు వాడుకోమంటావా? నాకు అర్థమైంది. ఈయన పాయింట్ నాకు ఏమంటానంటే, ఈ అబాప్ సర్వర్ ఎత్తేసి నీ ప్రోగ్రామ్ అన్ని ఎక్సెస్ ఇంజిన్ మీద రన్ చేసుకో అంటున్నాడు. కానీ అది నిన్నేం చెప్పిన అర్థమైంది. నిన్నేం చెప్పినప్పుడు ఎక్సెస్ ఇంజిన్ ఈజ్ అన్ అప్లికేషన్ సర్వర్. When you want to deploy applications onto it, it only supports a native framework. Edi SAP UEFI, OData service or JavaScript or some backend. These applications are native, which you can deploy it on Access Engine. If you write an ABAP program, how will you deploy it on Access Engine? Application server, it should be able to run those programs, but your Access Engine cannot recognize ABAP. That's the concept. ఇప్పుడు టామ్ క్యాట్ ఉంది, అది కూడా అప్లికేషన్ సర్వర్. జావా అప్లికేషన్ రన్ చేయొచ్చు, అబాప్ ప్రోగ్రామ్ రన్ చేస్తావు. సో అప్లికేషన్ సర్వర్ కెన్ రన్ specific to what? So Access Engine has got capabilities to run execute applications which are developed with HANA native framework. ఇప్పుడు SAP UEFI, OData services, ఇలాంటి సర్వీసులన్నీ ఆ Access Engine మీద రన్ చేసుకోవచ్చు. అబాప్ ప్రోగ్రామ్ ఆ సర్వీస్ మీద రన్ చేయాలి, అది నా పాయింట్. సో అబాప్ రన్ చేయాలంటే అబాప్ సర్వర్ ఉండాల్సిందే. అది నాన్ నేటివ్ అవుతుంది. when it is non native, you have to use dedicated application server system. అంటే అబాప్ I said ABAP.NET Java, all this will be what? Non native. దాని రెస్పెక్ట్ దాని సర్వర్ ఉండాల్సిందే. ఇఫ్ ఐ డెవలప్ మై అప్లికేషన్స్ ఆన్ HANA నేటివ్ ఫ్రేమ్వర్క్, ఐ కెన్ డిప్లాయ్ ఇట్ ఆన్ ఎక్సెస్ ఇంజిన్. అది నా కాన్సెప్ట్. HANAలో అప్లికేషన్ సర్వర్ ఉంది, ఎక్సెస్ ఇంజిన్, కానీ అన్ని ప్రోగ్రామ్స్ నేను దాని మీద రన్ చేయలేనన్నా. దాని మీద రన్ చేయగలిగిన ప్రోగ్రామ్స్ కొన్ని. అబాప్ ని, .NET ని, జావా అవి ఎత్తుకొచ్చి దీనిలోకి వెళ్ళాను తప్ప. ఎప్పుడు అబాప్ అయితే సపోజ్ నేను నేటివ్ ఫ్రేమ్వర్క్ తో డెవలప్ చేసుకున్నానంటే నాకు వేరేది ఏముంటుంది, HANA ఉంటుంది, ఫ్రంట్ ఎండ్ బ్రౌజర్ ఉంటుంది, అంతే. If I'm developing an application, let's say I develop my ERP product with SAP UI5 and OData services with HANA backend, ECC I can develop my own custom application by using UI5 and OData service, and I can develop my full end-to-end application and then run it. Then what happens? All my application is running on Access engine, na HANA database in browser ante. నాకు ABAP server ఉండదు, ABAP programs ఉండదు, ఏం ఉండదు. అది HANA native development. మళ్ళీ స్టాండలోన్ అంటే నువ్వు మళ్ళీ ఎంటర్ప్రైజ్ HANAకి వెళ్తావు. స్టాండలోన్ అంటే యూ ఇన్స్టాల్ HANA స్టాండలోన్ డేటాబేస్, యూఆర్ యూజింగ్ ఇట్ ఫర్ డేటా ప్రాసెసింగ్, దట్ ఈస్ HANA డేటా మార్ట్ అంటాం. HANA డేటాబేస్ వాడుకుని నువ్వు కస్టమ్ అప్లికేషన్ డెవలప్ చేస్తున్నావు, HANA నేటివ్ డెవలప్మెంట్ అంటావు. నిన్న చెప్తాంట కదా, ఫర్ ఎగ్జాంపుల్ నాకు SAP HANA అప్లికేషన్ ఉంది, నేనేమన్నా I got ECC application ఉంది, అన్ని ఉన్నాయి. So I wanted to have one custom application where I can handle all the bidding process. ఇప్పుడు SAP లో నేను పర్చేజ్ రిక్వెస్ట్ పర్చేజ్ ఆర్డర్ రేజ్ చేస్తున్నాను. ఓకే, బాగానే ఉంది. And once I raise a purchase order, I issue this to multiple suppliers, and every supplier should do his quotation. ఇప్పుడు నాకు అట్లా కాకుండా they give me quotes offline and I enter that into system అనుకో. If the person who is entering those quotes is being manipulated, for 100 rupees చెప్పి నేను ఏం చేస్తా 200 ఎంటర్ చేస్తాను, ఆర్డర్ రాదు. అట్లా కాకుండా what I want is I want to develop an application where my vendors can log in through a web-based application and give their quotes. అలాంటి అప్లికేషన్ తయారు చేయాలనుకో. అప్పుడు ఏం చేస్తా, by using SAP UI5 I'll design a front-end screen where how a vendor can log in, he can enter the PO order, item list and the quotation, all this of screen తయారు చేసి I'll develop a OData services to bind the data through which I can insert data into the database and develop an application and give this URL to my vendor. All my vendors, I send in the purchase order, in the link is sir. For quoting, please use this below link for all your quotes. Then he'll read through the entire PO, and then when he wants to give the quote, he just click on the link. Every vendor would click on the link, which opens them a web-based URL where they just give all the details about the quotes, and they click on the button save. And this quote details will get saved into my backend database, and these quotations can be used for further workflow. సో ఇలాంటి అప్లికేషన్ తయారు చేసాక నేను HANA నేటివ్ వాడొచ్చు కదా అంటున్నా. నువ్వు అడిగిన క్వశ్చన్ యాక్చువల్లీ కొన్ని క్రోర్స్ వాల్యూ. నాకు ఇప్పుడు ఏంటంటే ఇఫ్ యూ క్యాన్ డెవలప్ సమ్ కస్టమ్ అప్లికేషన్ ఆన్ బై యూజింగ్ HANA, SAP అమ్మొచ్చు, కొనుక్కుంటాడు. కానీ ఏ కాన్సెప్ట్ తయారు చేయాలో జనాలకు అర్థం కావడం. Because name the requirement, there are ready-made applications already available. You have to come up with some very beautiful concept through which you can develop an application. మన SAP దాంట్లో వాడు కార్ పూలింగ్ చూపించాడు. They have developed a car pooling application by using this HANA native development. అంటే we want to demonstrate real time అంటే ఎట్లా అంటే, let's say I కార్ పూలింగ్ అంటే వేరే కార్లు నేను ప్లేస్ చేసుకుంటా కదా, వాడు వస్తున్నాడు, I book కార్, ఓకే, వాడు ముందు రోడ్లో టర్న్ తీసుకుని నాకు మెసేజ్ వస్తుంది, వాడు ఆల్రెడీ వేరే రోడ్ తీసుకున్నాడు, ఇంకో కార్ బుక్ చేసుకున్నాడు. అది రియల్ టైం అన్నమాట. వాడు యాక్టర్ లెఫ్ట్ తిరుగుతానే నువ్వు ఎక్స్పెక్ట్ చేసిన రోడ్లు రాలే, ఇంకో కార్ బుక్ చేసుకుంటాడు. అది రియల్ టైం. సో దట్ ఈస్ లైక్ వెన్ యూ వాంట్ డెవలప్ ఓన్ కస్టమ్ అప్లికేషన్ డెవలప్మెంట్, యూ గెట్ ఇన్ టు దట్ కైండ్ ఆఫ్ లేయర్. సో డిడ్ యు అండర్స్టాండ్ నౌ పుషింగ్ డౌన్ లాజిక్ కోడ్ అంటే అర్థమైంది. Okay, so we'll continue tomorrow. That's fine. Thank you. Uber is using HANA for cabs. Yeah. Uber is using something called .js, which is .js framework.